Okay, guys, welcome back. This is day 8 of SHM, and in the last class, I've talked about the angular SHM. It's not just the linear oscillations where the particle is just oscillating on an axis or a straight line. We can even consider the bodies when they are oscillating like this. Then, when the oscillations are angular, the displacement is angular, the body can oscillate like this. I've even given you an idea saying in those problems, you don't find the restoring force, you find the restoring torque, and the restoring torque will be proportional to minus theta. So alpha will be proportional to minus theta. And we do the further calculations to find the time period and all. We've done some questions like this yesterday, right? Let me give you one more question on that. Then we shift our focus to compound pendulum. I believe I gave you a question on compound pendulum. Some people gave me the answers. Ganesh or Sharad, someone, one of them actually gave me the answer. It was right. It was correct. I think it is Ganesh. Anyway, so I'll teach it. I'll start from the beginning again today. Angular SHM. I gave you a question like this yesterday. Connect a spring to a disc which is hinged here, and I asked a time period, and we done this kind of problem yesterday. And why don't we do another problem saying, which is a similar problem again. This is a problem that Raghav asked me a while ago. Raghav, are you there in the class? There are two springs K1, K2, the rod of mass M, and length of the rod is L. Okay, Raghav asked this question once. Try, go ahead, do it. Like this is hinged in the middle. Try to find the time period of the rod. Try to do it as quick as possible. It's at your pace. Aniket, what is it?
Sir, for the top one, we can just say the energy, if we differentiate it will be 0.
What?
So for the top problem, sir,
No,
that
there will be a
spring,
rotational kinetic energy, right? Half I omega square, half kx square.
yes, sir. So if we differentiate it, it will come 0, right, sir? With
Are
that, we can do.
you talking about the total energy?
Yes, sir.
Yeah, total energy can be differentiated and equated to zero. Yes, you can do that. Yeah.
Yes, sir.
I mean, did I discuss that process with you people? I'm not sure. I'm not sure about differentiating the energy method. But why don't you people do this? The question right in front of you. Find the time period by doing what? Always displace it by an angle theta. It is displaced like this, so restoring torque will be like this. How do you get the restoring torque? I think this is L by 2 theta, so it expanded by L by 2 theta, so there will be a force K1 into L by 2 theta, and there is another force K2 into L by 2 theta, right? So you have both the forces acting on the rod and both the torques. If you have to write the restoring torque, both are creating the torque. So K1 into L by 2 theta into perpendicular, that force into perpendicular distance is again L by 2 plus K2 L by 2 theta into L by 2. Both the torques with a negative sign in the beginning. So this is how the restoring torque is written. Whatever the things that we have, minus K1 L square by 4 plus K2 L square by 4 theta, torque proportional to theta. So I write I alpha equals to this whole thing into theta. Alpha equals to this whole thing by I into theta. I in this case is nothing but for the rod, it is ml square by 12. Since it is a rod, you put it there and you find the value, whatever the value that you get. Shall we do it? Why not? K1 plus K2 L square by 4, L square cancel, 3's. So alpha equals to minus 3 K1 plus K2 by m theta. So the time period will be 2 pi root over m by 3 into K1 plus K2. Raghav, if you have time, open the textbook and check that question if you're right or not. Or if I did a calculation mistake, please let me know at any place. But I think this is the time period for the rod. Okay. So that's simple. It's quite easy to calculate the time period like this. Shall we do another question on that? We can do a lot more questions. Hmm. Yeah, Raghav, you check it. Angular SHM. Can I think of any other problem which is complicated? Nah, forget it. When you come across any other difficult problem from Angular SHM, we'll do it then. Okay. Let us talk about a compound pendulum now. Let's talk about a compound pendulum. Now, a compound pendulum, like I mentioned yesterday, any body which is hinged at any point and being oscillating like this, it's a compound pendulum. A simple pendulum, you don't have any mass anywhere. You have a point of suspension, you have a long string, and then there is a mass. Point of suspension, long string, and there is a point mass. Even the mass is considered as a point mass in simple pendulum. Now we are talking about a compound pendulum. Yeah, Sharath, if you have a doubt, please raise your hand. Now we're talking about a Sharath. Sharath, what is it?
Sir, like I have the system, sir. Could you just tell me whether it's an SHM or not?
Yeah.
So there's a block in the middle and it's connected by springs on its opposite sides.
Uh-huh. Do you
And
want
then
me to
we
draw it?
give, yes, sir.
Just a second. Okay. Now?
And some force is given vertically, sir.
Okay.
So like, does it come under SHM?
Mm, it might. Because if this is a free equilibrium position, somewhere around here, this is where the equilibrium position is. Okay. And if the oscillations happen along this point, you have to take the spring constant k cos square theta, k cos square theta. Do you remember that? And
Yes, sir.
just normally solve the problem. Don't ever give me because there is an external force acting on the body. Okay, let them act. It's totally fine. They will simply change the equilibrium position. That's all. Okay, it will never affect the time period of the system. But in this case, yeah, it is affecting the time period because k cos square theta, k cos square theta is varying, right? So
Sir. Here, like, it's not about the horizontal motion, sir. About the vertical motion.
so you're talking about an
Follow.
oscillation like this.
Yes, sir.
Why would it oscillate like this?
So it has
Acha,
straight
you're
stretch, sir.
making
So
it
like,
oscillate like this.
yes, sir. Because of the force will oscillate, right?
Oh, then it's a very difficult, I mean, different case altogether, in my opinion, because like you have to write the restoring force in this direction. So you have to take the kx, you have to take the kx, write the restoring force in this direction, and solve it. I mean, you can solve it like you always like you solve all the other
Excuse
problems,
me,
but
sir.
writing the restoring force will be a little different compared to others. Aniket, yeah.
In this, if the
So
two Ks are different, how to do, sir? I got this doubt in one sum.
What?
If the two Ks are different, sir, like K1, K2, at an angle.
Then k1 cos square theta 1, k2 cos square theta 2. What's a big deal?
Oh, okay, sir.
Yeah, Sharath, you're saying something.
sir, nothing, sir.
Yeah.
Like, sir, like, does it come under SHM?
Try to find the restoring force. If it is coming proportional to x, this displacement, if it is proportional to x, yes, it is SHM. But I'm not sure
Okay.
it would come it as proportional to x. I'm not really sure, but why don't you do it and let me know? Okay.
Yes, sir.
So let's get back to that compound pendulum thing. I'm taking any random body whose center of mass is here, but we didn't hinge it at the center of mass, we hinged it somewhere around here. We hinged it somewhere around here. Now we made it oscillate, so it's as if the body has to turn, the body is turned like this and oscillating. So the center of mass will move somewhere up here because of this oscillation. Let us say, let us take the distance between the center of mass and the point of suspension is d. Now, all we have to do is find the restoring torque. How do we find the restoring torque? Mg acting, Mg is the only force that can create the restoring torque. Mg into perpendicular distance. How much is this perpendicular distance? This is d. If this is theta, this is d sine theta. So the restoring torque will be mg into d sine theta. Again, since the oscillations are considered to be really, really small, of course, there is a minus mg d. In the place of sine theta, I'm just taking theta. Okay. So torque equals to minus mg d theta. Now torque is nothing but I alpha. Alpha equals to minus mgd by I into theta. Now, I is the moment of inertia about the point of suspension. Please remember that. Okay, let's call this as P. Okay, so I is about IP. Moment of inertia about the point of suspension. Please remember that point. D is the distance. So the time period will be 2 pi root over IP by mgd, where distance d is nothing but the distance in between the point of suspension and the center of mass. Okay, so let's just start with a easy question. Okay, let's start with the easiest question that we can find. As why don't we discuss the question that we did yesterday only? Ganesh will give us the answer to check. He did it yesterday. So this is a point of suspension. To find the time period, here you can generalize. The time period is nothing but 2 pi root over I about the point into mgd. Sorry, mg into d. So the time period equal to 2 pi root over I about this point. It's nothing but you have to write the moment of inertia, shift of moment of inertia. So it is ml square by 12 plus m into the distance is L by 4 whole square by mg into the distance is L by 4. So this is the time period. I hope this is the answer that you got yesterday, Ganesh. So this is how you simply do it. Let's start with another problem that which is from H.C. Verma. There is a ring which is hanging from this point. Like there is a nail or something which is hanging from that point. Now the ring is oscillating like this. The ring is oscillating about that point. Can somebody directly give the time period? Raise your hand and speak. Direct answer. Time period. I want anybody. Did everyone die? Did I travel back in time to the rock age? Hello? Alright, come on, guys. 2 pi root over I about this point P of suspension by mgd. So the answer will be Harsha has an answer. Harshavardhan, give me the answer.
2 pi into root over 2r by g.
2r by g.
Yes.
Let's check. The moment of inertia about that point is for a ring is 2mr square. Agree? By m into g into r. You got the moment of inertia wrong, I guess. So r, m, m. So 2 pi root over 2r by g. Did you say 2r by g? Harshavardhan, he gone again. So yeah, this is the answer for a ring. There are questions for the disk. There are questions for different bodies. Okay, like there will be questions of a squarish plate hanging from one of its corners. Find the time period of this thing. Can somebody immediately give the answer? I'll give you a chocolate. I'll post it. I'll send you via courier. Nobody? Come on, guys. You just lost a chocolate. Even girls. Nobody is willing to answer. Mazida, there is no fish market today. Why are you not talking today? The time period t equals to 2 pi root over moment of inertia about this point. Yeah, Harshavardhan.
2 pi into root over mg into L by root 2 by ml square by 12 plus ml square by 4, sir.
No, first of all, moment of inertia must be in the numerator. Yeah. So the moment of inertia will be ma square by 6
Sir, I got it. Like 2 pi into
Plus
root over 7 root
m
2 by
into,
12.
let me try, a
G.
by root 2 whole square. A is the side of the square plate, m is the mass, into m into g into a by root 2. Sharad, do you agree?
Yes, sir.
Yeah, I think the answer is right now. Okay, so every time you face a compound pendulum, no matter what kind of a body they're giving, you can directly write the time period. I don't think there is that big of an issue to write the time period anymore. All right, now let's go through the problem that Vamshi asked now. So instead of some point mass, what happens if you have a sphere at the end of a pendulum? Now you consider this as a compound pendulum and try to find the answer. Instead of just taking this as mass m, consider this as a sphere and the center of mass is at a distance, and write the moment of inertia of the sphere about this point of suspension ip, and try to write the whole time period and do it. Okay, Sharath, I hope you get it now. So this is a question from H.C. Verma, yes. Question number 51, if I believe it right. Okay, now once those questions are over, I'll have to talk about the torsional pendulum. Okay, now this is a interesting bit. The torsional pendulum. Does anyone know what torsion means? Anybody? Torsional pendulum. My writing looks like a doctor, right? Nobody can make out what I'm writing. So yeah, torsion. What does it mean? Is it something related to spinning? Yes, Sharath, it is a bit related to spinning. Nobody has an idea what torsion means. Yeah, torsion means rotating, but it's like, do you remember? Oh, if I can find a string here. No, I can't find anything in my room. Uh, no, I can't. There's nothing here. Anyway, yeah, I'll try with this mouse. I'm not sure if the mouse will work for me. Just wait a second. The thing is, like, there is this mouse, okay? Now, 1 second. Now, the thing is, if the mouse is oscillating like this is like a not a simple pendulum. Obviously, it's a compound pendulum. This is not a point mass, so this is a uh, uh, compound pendulum. Now, what about the body is not oscillating like this? It is sitting straight, but it is oscillating like this. Oh, it's not oscillating. But check this. It's oscillating like this. If it is oscillating like this, you all might have seen this thing. In fact, in the definition of simple pendulum, they clearly mention that a torsionless thread. They don't want the body to oscillate like this. If the body is oscillating like this, the time period totally gets affected. Okay, yeah, the twisting like thing that you see this kind of a twisting. If a body oscillates like this is called as a torsional oscillation. Okay, this brings a whole different. It's not really affecting it that much, but if you're doing a simple pendulum problem, you make sure it's not the string doesn't have any torsion. It is about the torsion in the string. Like if it is twisted already, if the string is twisted, let me twist it and damage my only mouse, the only mouse that I have in my home right now. You see that? If it is twisted, there will be this rotatory motion, right? So that is called as the torsional pendulum. Now, the idea how to write again the torsional pendulum again is an oscillatory thing. It's an angular SHM only. It's like a different type of an angular SHM, except instead of body oscillating like this, the body, I'm not sure you can see this, the body is oscillating like this. That's the only difference. So even though in this case of torsional pendulum also, you have to write the restoring torque only, the torque restoring only, except that restoring torque is a torsional torque. How do you find the torsional torque? You cannot. Right now in this topic, you cannot. It comes in the topic of properties of material, which is in the elasticity topic, which is probably the next, or I'll see where it sits and we'll decide. So in that topic, we will let you know. But for now, they clearly give you the torsional torque is proportional to theta directly, and they give you a constant. This is a torsional constant or anything like something like that. They directly give you this value. So torque equals to k theta. You don't even have to put an effort. All you have to do is write this moment of inertia of the body about this axis. Now, this is very thin, so it is 0. But strictly speaking, if I take my phone, the phone is in the torsional oscillation. I have to write the moment of inertia of my phone about this axis. Okay, so any body, like let us take a random body, let's take a square plate only. It is making a torsional oscillation. It's like oscillating about that thing. So it's not making an oscillation like this, it is just twisting. You have to find the moment of inertia of this square plate about this axis, which is ma square by 12. You have to put that moment of inertia, write alpha equals to minus k by I and all. And the time period is again 2 pi root over I by k, that's all. The k value, they have to mention it. If they don't mention the k value, you can't do anything about it. Okay, the k value has to be mentioned in this topic. But once the elasticity topic is over, they might not mention it. So in the final question, final mains paper, they might not give it. They might not give you the value of k. There is a chance that they might just skip it. So you be careful. But in this topic, they will directly mention that in the Hitsi-Verma topic, they clearly give you the torsional constant of this string. Clearly, check this. So these rods, they oscillate like this about that thing. They're not oscillating like this. They're just twisting about this thing. It's oscillating like this. Okay. So it's an interesting thing. Try that problem once. Okay. Now, once this thing is clear, once that part, like water sprinklers, yeah, water sprinklers kind of go in the oscillation, but it's not because exactly of torsion. Okay. They have some
So can we do like this oscillation and the normal pendulum one mixed together?
Why do you want to go to Russia?
No, sir.
This is already difficult enough for you people, right? So
Okay, sir.
yeah, you can do it. You can definitely do it, but it's a long procedure. Ow. Long procedure, so we don't do it right now. Okay. Now, once this part is clear about torsional SHM also, I thought it would take more time, but yeah, the angular SHM and the torsional SHM is also clear. Now, let's talk about the final last topic, the combination of SHMs. Now, what is a combination of SHM? How can you combine two SHMs? We can do it theoretically or we can do it practically. Since we all love it doing it practically, so let's talk about them practically first of all. Okay, it's like, let us say there is a block, there is a room, empty room, which is connected to a spring or two springs. It's executing an SHM. Okay. Now the problem is inside this room there is another block with fixed two springs. So this is oscillating and this is oscillating. What is the final motion of the oscillation of the block? Can anybody give me any answer regarding this? What is the final oscillation of the motion? What is the final resultant motion of the block? How would it actually look? Aditya has an answer. Aditya, yeah?
Sir, I am thinking like let's take at when it goes at the extreme positions.
Uh-huh.
First the above block, then this below block, sir.
What?
So can I say one idea?
Sir, I have
Yeah.
an idea, sir. Can-
So it might be like we can just draw both the phases together and it'll go with a phase difference.
Oh wow, somebody's using his brain finally. Okay, Sharad, what do you have?
Sir, like, can we consider this like some, like there's an extra force acting on the block which keeps on changing.
Mm-hmm.
So, like, we'll have to do some sort of
Oh, I totally
integration.
forgot forced and damped oscillations. We'll see. If I can do it today, I'll do it today. Otherwise, we'll do it tomorrow. Yeah, what were you talking about?
So like, can we consider like there's some force which keeps
That
acting
will
on the block,
complicate
and
it way too much.
then we
If
try
it is
to.
that complicated, I wouldn't have discussed it in this class, right? So let me
So we
simplify.
can just take the phase difference and work with that.
Yeah, Aniket, finally you're using your brain because someone is helping you.
No, sir.
Your future self time traveled
Uh,
to today and giving you information or anything like that. Then
no, sir.
why are you using your brain this level to this level? Let me talk about it. We'll have to the first thing that we need to do is, again, we have to consider a special case where the omega of this body and the omega of this body are equal. If the
That's when we can
omegas are
take the phase
difficult, so if the
difference.
omegas are different, it is almost impossible to guess the kind of motion the block will go. It's like a chaotic pendulum. You might have seen this thing. I've shown it to you in the past. They'll randomly go everywhere. I mean, the block will randomly go oscillate like this. Okay. Here the frequencies, I'm considering a special case where the frequencies are equal. This is the only case we can study. If the frequencies are not same, it becomes almost impossible to study that whole resultant motion. So we are considering a special case where the frequencies are equal. Sharath, what is it?
So like, if the frequencies aren't equal, then we'll have to go with that force method, right?
Yeah, I would say that if the frequencies are not equal, then you'll have to go with that method. Even then, it's a very, 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 very extremely difficult
I'm
thing
taking
to follow if the
process.
force, if the frequencies are it's not difficult. Sorry, it's not same. If the frequencies are different, it's a very, very difficult thing. So we don't talk about them at all. But if the frequencies are equal, we have a good thing. Now, so I'm only taking a special case considering same frequencies. So the whole topic from this point that we are going to talk is about the same frequency problems only. We're not even talking about when the frequencies are different. Now, when the frequencies are same, there are again different cases. There could be a SHM where both the SHMs are started at the mean position at the same time. Both are going to the extreme at the same time. Both are coming back. Both are going to the extreme at the same time, and both are coming back at the same time. It's like my hand and the small block. My hand is also in SHM. The block is also in SHM. When the block moved to extreme, the hand also moved to extreme. They both came to the mean position at the same time. Why are they coming at the same time? Because the frequencies are same, because the time periods are same. So they're both going to the extreme at the same point, coming back, both are going to the extreme, coming back, both are going to the extreme, coming back, and it's constantly happening. You getting my point? Now, when this is constantly happening, when both the amplitudes are constantly happening, I can clearly say this is an SHM with an amplitude combined. That's all. So if the SHM amplitude of this thing is A1, the amplitude of this block is A2, I can simply, if I only like I put a radium sticker on this thing, and I'm only observing the block in a dark room. I don't even see the springs. I don't even see the box or the room. What I'm looking at is only the block. It will simply oscillate in an SHM with an amplitude A1 plus A2. It will go to A1 plus A2, come back to minus A1 plus A2, and come back to the mean portion. So this is an SHM where the bodies are simply going to the extreme with, so there is only one body, then there are no bodies. Okay, there is only one body is going to A1 plus A2, coming back, is going to minus A1 minus A2, coming back. It is simply an SHM with an increased amplitude. How do I look at it mathematically? Equation of first SHM is A1 sine omega t. Equation of second SHM is A2 sine omega t. If I want the resultant, Y resultant, or I can write all of them as X, okay? If you really want it as X, since we're only considering horizontal SHMs, I can write A1 sine omega t plus A2 sine omega t. Since displacement is a vector, we can directly add them. Okay, the algebraic sum will simply give us the resultant displacement. So the resultant displacement simply looks as simple as this: A1 plus A2 sine omega t. They consider this case where There is no phase difference in between them, in between these two SHMs, no phase difference. You get it? I hope you all get it clear. Now let us talk about the second case. The same problem, same frequency. Again, I'm telling you, I won't even discuss if there isn't same frequency. So same frequency problem, same box, everything is same, omega, omega. Except what's happening this time is when the block is going to positive extreme, the room is going to negative extreme. And it is like opposite in direction. So I am trying to go to A1, but the block is going to A2, sorry, minus A2. And when both coming to mean position at the same time, going like this. So because of this, what will happen? Can anybody tell what will be the resultant motion? Anybody? No? No answer at all? What has happened to you people today? Yeah, Aditya.
A1 minus A2, sir.
Exactly, A1 minus A2. It's as if I have this coin, okay? This will go to A1, but this will go to minus A2. Both will come to mean position. This will go to this, but this will go to this thing. So because of this resultant motion, what will happen is like I'll try to show it on this thing, okay? This will go to A1, but the room will go to minus A2 at the time. Now, when this will go to minus A1, the room will go to plus A2. Because of this constant hustle, like they will cross each other at the mean position, they go to the opposite point. So constantly, we can clearly say the resultant amplitude will be A1 minus A2. So if only I'm observing only the block will simply look like it is going to A1 minus A2 minus of A1 minus A2. That's all. Now, theoretically looking at it, one SHM equation must be A1 sine omega t. Can somebody tell me what is the other SHM equations? Can somebody tell me what's the other SHM equation? Aditya.
So directly write it as A2 cos omega t, sir.
No, it didn't start at the extreme position. Both started at the mean position only. Both started at the mean position only. But one is going to positive
So
extreme.
180 degrees should I write, sir? Then pi.
Exactly. One is going to positive extreme, the other is going to negative extreme.
So pi is the
So
difference.
plus 180 degrees. Do you get it? Sharat,
Yes, sir. Plus or minus anything doesn't matter here, na, sir?
What?
Like it's plus or minus, sir.
Yeah, it doesn't matter. You can write omega t minus 180 degrees or omega t plus 180 degrees is also fine. Sharath, I think I mean, which part did you miss? Where one block is going to the block is going to A1, but the whole room which is containing it will drag it back by A2. So effective amplitude won't be A1, it will be A1 minus A2 because of the block coming back in the opposite direction. So theoretically looking at it, this can be written as minus A2 sine omega t. So when I look at the resultant displacement, X resultant will be A1 minus A2 sine omega t. Okay guys, so this is where they say the phase difference are the opposite in phase. They are opposite in the phase. Okay, so whenever they are opposite in the phase, the resultant amplitude will be A1 minus A2. When they are in the same phase, the resultant amplitude will be A1 plus A2. Okay, now the question is, yeah, we had a good idea saying if they're in same phase, it's easy. If they're in the opposite phase, it's also easy. What if they have some phase difference? We need today notes. Sorry, yeah, I will give you the today's notes. So what if the phase difference is not 0, not 180, some random angle? What if it is 90 degrees? What if it is some random value? How do you do it now? Now this is where
So
the
make
problem.
anyone at mean, sir, and see the phase difference and do it as usual, what we did with
No, the
180
problem,
degrees.
this is where the problem is like now from this point onwards, it is not easy for you to intuit it because The block started at the mean position. By the time the block started at the mean position, the whole room carrying it is already at some position. So it will be so difficult for you to intuit it. So now we cannot approach it practically that easy. Okay, it's not easy to approach the problem practically. So from this point onwards, I'm going to approach it theoretically. Look at it. X1 equals to A1 sine omega t, X2 equals to A2 sine omega t plus some delta. That delta is the phase difference in between these two things. Aditya, do you get it? Aniket, somehow you
Sir,
can.
I told this thing only, sir.
Yeah. So wait a second. Sharath is saying, sir, will it be given question are supposed to know whether the room and the block are in the same? Yeah, in the question they'll definitely mention whether both SHMs are in. What do you say? Whether they are in phase or out of phase, or there a phase difference, they will definitely mention. Okay. So let us talk about them. There is some phase difference. Like, let me give you give you some problem, some random problem. Okay. I'm taking some vertical block systems now. So this is oscillating, both are omega again, omega again, omegas are same. This is oscillating, the room carrying it is also oscillating. So it is difficult to intuit the resultant motion of these two things if they have a phase difference. If they're going at the same phase, going to the extreme, going to the mean, going to the negative extreme and coming back to the mean position at the same time, if the whole thing is happening at the same time, it is easy to intuit. It is easy to say simply A1 plus A2 or A1 minus A2 when they're in the opposite direction. But when the phase difference is some random angle, it gets difficult. So this is where people love to use some trigonometry to solve this equation. X resultant equals to x1 plus x2. They write A1 sine omega t plus A2 sine omega t plus delta and all. They open this equation, try to write into a different equation, but I don't like that method. Okay, because it's not so intuitive. It is not, I mean, it looks like a mathematics class from that point. If you have to do it and solve it, they will arrive at an answer saying root over a1 square plus a2 square plus 2a1 a2 cos delta sine omega t plus some phi. They will randomly arrive at this thing, but we don't know how we got there. So to solve this, to get the answer from this, I have another intuitive method. I'm not saying it is easy, but I would say this is intuitive. This is an interesting way to put it. Like Aniket said, we will take phasors, but we are going to draw both the phasors in a same diagram, not different phasor circles. We both will be drawn in the same circle. Watch how it happens. Okay. I'd like to do this on a different page so that you'll get some more clarity on that. XY axis. Why is it drawing with my hand? Shouldn't. Nope. Okay. So one SHM goes like this, whose amplitude is A1. So it is going from A1 to minus A1. Let us say it started at the mean position only. So the baby is at the mean position. The mummy of this thing is here only. The other SHM has a bigger amplitude, so it will have a bigger circle whose amplitude is A2 minus A2, and this particle is already at some phase. It's already moved and somewhere near the positive extreme. It's not at the positive extreme, somewhere near the positive extreme. So her mummy will be somewhere around here. So I'll draw a big mummy and a big baby. That is for the bigger SHM. Okay. So I'm going to draw them both. Clearly observe. This line is going to represent, whose length is A1, is going to represent the smaller SHM. This line is going to represent the bigger SHM. And this angle in between them is nothing but the phase difference delta. All we have to do is a simple thing, which is nothing but taking the resultant of these two, find this resultant length. How do we do it? Remember from the vectors, root over a1 square plus a2 square plus 2a1 a2 cos delta. This value, the length of this thing, will be the new amplitude of the SHM. That is the interesting part. If you have two SHMs which are varying their, what do you say, the amplitudes are not in phase, but you have to talk about the combination of SHM. This is how you find the resultant amplitude. It is not easy to think about it. We cannot easily think about it, but using the phasor diagram, which is a lot more easier way to put it, we can use the phasor diagram and try to find the resultant of this and this using the phasor whose length is root over a1 square plus a2 square plus 2 cos, sorry, a1 cos delta into a1 a2, of course. This is how you find the final resultant amplitude. So somebody gives you a problem, like let me give you a problem which is very simple. Okay, somebody says a problem where two SHMs, combination of two SHMs, one is at the mean position, the other is already at extreme. They clearly mentioned that SHM started from the extreme. One SHM started from the mean. At the same time, the other SHM started at the extreme. So the SHM equation will be x1 equal to a1 sine omega t, x2 equals to a2 sine omega t. Since it started from the extreme, I'll put a 90 degrees. So what will be the resultant amplitude? A resultant equals to root over a1 square plus a2 square plus 2a1 a2 cos 90 degrees. So the answer is simply root over a1 square plus a2 square. So this is nothing but a1 sine omega t. This is nothing but a2 cos omega t. And this was the question from the DPP in the day 1 or day 2 or day 3. I don't remember. The question directly says there are two SHMs. x1 equal to 3 sine omega t. x2 equals to 4 cos omega t. This is a1. This is a2. The phase difference is 90 degrees. So the x resultant must be equal to root over 3 square plus 4 square sine omega t plus some phi. How do you find the phi? Even that, do you remember tan phi equals to b sine theta by a plus b cos theta? Or like, let me write it properly. In the vectors, when you write the resultant, do you remember how we used to write the tan phi value? A2 sine theta by a1 plus a2 cos theta. You find the phi angle, you put it there. If they ask you this value, if they don't directly give the amplitude, answer as phi. This is how you write the combination of SHM. Okay, am I clear with the combination of SHM? When the SHMs are in the same direction, it could be a little clumsy and difficult to understand in the beginning, but if you find it difficult, I suggest to watch this class slowly again. You will definitely make it. It's not over yet, but this last bit, I would say this is definitely the last bit, leaving the damped oscillations ahead side to the side. I will talk about the damped oscillations once I get the clarity that how much is it even there in your syllabus or not. I have to check it whether it is not in your syllabus or not. I'll check it and let you know. But today this is the last idea. What if, you must get this doubt by now, what if the combination of SHM is happening like this? How would you do it now? How would you write the resultant of SHM like this, like in this case?
Sir, it's just like my doubt,
Sir,
sir. But
first
instead we'll
thing,
have
sir,
to put
let's
it.
neglect this internal block and think about the bigger block only and make the phasor diagram. and then the small block and make the phasor diagram, combine the
First of
phasor
all,
diagram,
if
do
you
the
write the phasor diagram, it is not really appropriate to think about it because
The
because
directions are different.
SHM of this thing is like this. The SHM of this thing is like this. The resultant motion will be it will be everywhere. Again, let us consider the special case where the omega is same for both the systems. The time periods are same for both the systems. Both start at the mean position at the same time. This part, like, let me show it on my thing, my phone and the coin. Let us say my phone is oscillating vertically, coin is trying to oscillate horizontally. Let me just stop the screen sharing for a second and show it on the big screen. I'm not even sure if I can do this. Are there any? No, nothing happened. So, or should I take something which is smooth?
So you can take the other side, right? The one with the camera.
What can I take?
So the one with the camera instead
have
of
the
placing
remote.
it on the screen.
I have the remote. Okay. So this thing is oscillating horizontally. The remote is horizontally vertically. Sorry, oscillating vertically. Now, both the time periods are equal, let us just say. We're considering both the time periods are equal. Now, let's talk about a special case where you getting my point, right? The frequencies are equal.
Sorry, sir, you are sharing your
the
screen.
Oh,
screen sharing is not on.
fine, leave it. So anyway, the frequencies are same. Let us talk about case where both are starting from the mean position. The coin went to extreme. The phone also, the remote also went to extreme. Came to mean, extreme, mean, extreme, mean,
It is like a
extreme.
linear motion, sir.
It's like
So the
some
coin
SHM
looks
has
like
already.
it goes like this. How do I prove the motion? Now that is the first
So
question.
like
That
you
is one
can,
question. The other question is what happens if there is a phase difference in between them? Like if it is 90 degrees, this go to negative extreme, this go to positive extreme. So now the motion looks like this. So the coin moves like this. So if the phase difference is 0, the coin looks like this. The phase difference is 90, the coin looks like this. Now if the phase difference is 90 degrees, this is very interesting. The the remote is already at mean. The coin is already at extreme. When the coin comes to mean, remote goes to extreme.
So it's a square.
square.
Does it look like a square?
Yeah, rhombus, sir. Say it rhombus.
No,
It's a circle.
it is basically an ellipse. It's an ellipse. You will definitely
Ah,
get it as an ellipse. Okay, I'll show it to you. I'll show you how to do it. Just check this thing. Let's
Sir,
do
I
it.
have an idea for this.
The SHM equation of this thing is y equals to a1 sine omega t. The SHM of equation of this thing is x equals to a2 sine omega t. I'm considering the case where the phase difference, the delta is 0 beginning. In the beginning, case 1, let's write it as case 1. The delta is 0. The delta is 0. Y equals to a1 sin omega t, x equals to a2 sin omega t. If I write y by x, what do I get? A1 by
A1 by
a2.
A2.
So what I'm
yes.
getting is y equals to a1 by a2, which is a constant into x. What is this?
SHM equation.
You are an idiot. Y equals to mx.
Acha, M. What
So
is
we'll
X?
get some sort of curve.
What did we prove? That it will simply go in a straight line path. That's all.
Straight line.
It simply goes in a straight
Okay,
line
you
path.
put the path of it. Okay, like that.
Delta is 180 degrees. So x equals to, sorry, y equals to a1 sine omega t, x equals to a2 sine omega t plus 180. It will cause it, will make it minus a2
Minus.
Minus
sine
sign.
omega t. So y by x this time becomes minus a1 by a2. So it is still a straight line equation, minus a1 by a2 into x. Okay. Now you can see my screen, right?
Yes, sir.
Yes, sir.
Now, if the delta is 90 degrees, this is where the interesting bit is. If delta is 90
We'll
degrees,
get cos.
x equals to a1 sin omega, or y
90.
equals to a1 sin omega t, x equals to a2,
Cos omega t.
exactly, you'll get cos omega t, sin omega t plus 90 degrees is cos omega t. So I'm going to write y by a1 as sin omega t, x by a2 cos omega t, Shall we go ahead and write sine square omega t plus cos square omega t equals to 1?
Yes, sir. And then you prove it as an ellipse equation.
I square by a square plus x by a square a1 a2 square equals to 1. Do you remember this equation?
Yes, sir. It is the equation of ellipse.
Ellipse.
Equation of an ellipse. We proved it in the topic of gravitation. We've done it, right?
Where I think A2 is the length of the what we say semi major axis, sir.
Semi-major.
That is the semi minor axis.
I am glad you remember that you remember semi major and semi minor axis. But I'm not sure if I've done this in the classroom, but I think you people did it. Like you people actually came up with this equation, right?
Yes, sir.
I asked you people to prove this equation saying x square by a square plus y square by b square
So
equals.
this equation you gave in the video only, sir, itself.
Did I give it? Okay.
Yeah, you just need told us to prove the eccentricity, sir. Nothing
Acha,
else.
okay, fine. Yeah, Vamshi raised his hand. Vamshi, what is it?
I think I want to tell the answer, but
Okay, fine. So this is it, guys. I think we've done covering all the basics of simple harmonic motion. If I feel like I've missed any spot anywhere, I'll try to look into it today. Before I end today's class, are there any doubts? I will give the notes. But anything regarding the class, just the class. Aditya, what is it?
Sir, there is one question in DPP like there was a like take a hollow cylinder, some kind of thing, in some book I thought, and it is dumped into water, sir,
No, so
and there is going up and
that
down.
question can only be solved once you get the clarity in fluid statics. Okay, so we will solve that question in fluid statics where our body is dropped in liquid and it oscillates. Okay, so we will talk about it in the fluid statics. Okay.
Yeah, so is that an SHM also,
Yeah,
sir?
it is an SHM. We'll get to that question.
Okay,
Okay.
sir, that's what, sir.
Yeah. So that's it, guys. So that's it
Thank
for
you, sir.
today. I will cover, I mean, if I miss any topics, any more topics today, if I feel like I missed any other topics, I will definitely look into them and I will talk to you people tomorrow. Most probably tomorrow will be a problem discussion. If it doesn't, I mean, like if I missed any point, I will definitely cover in tomorrow's class. Sinusoidal is basically sine, like it's following sinusoidal. That's all, Vamshi. All right. Thanks so much, guys. Bye bye. See you again tomorrow.
thank you, sir.